Now we're going to look at how to graph a polynomial function. And like I mentioned, we're going to use our graphing calculators as an aid here, but we are going to go ahead and do some of the setup by hand. So here's sort of a summary of your process when you want to graph a polynomial function. First, you want to find the real zeros. That's what we spent section 3.2 and 3.4 working on. So we can do that in a lot of ways that we'll review as we work here. Those are your x-intercepts, so you'll plot those on the x-axis. Then you want to find your y-intercept, which is where f of 0 is. So whatever you get when you plug in 0, that's going to be your y-intercept. So after that, you're going to have a bunch of x-intercepts and you're going to have y-intercepts. You need to then pick some points for your table that are going to be between the x-intercepts and outside of the x-intercepts. That's going to help us kind of get the final shape of our graph, and I'm going to show you how to use the table function on your graphing calculator to help you do that as well. So let's look at this first example. We want to use these steps to graph f of x. Now, the first place that we're going to start is by finding the real zeros for f. Now, remember that the way we need to do that is by listing out our possible rational zeros and then either guessing and checking or using the graphing calculator to help us decide. And I would rather use the graphing calculator. So when we go here, okay, this is what your graphing calculator looks like. You're going to go to y equals and you're going to type in your function. So here is my function. Now, don't forget, if you're not sure, the variable button is right here. Okay, so you don't have to pick the variable depending on the mode of your calculator. It's going to choose it for you, and so that's where we're going to type in. And we got to this menu by going to the y equals button, and that's where we're going to type those things in. Don't forget also that this little caret button is how you get your exponents in there. And so now when we're ready to see the graph, we're going to go to the graph button over here. So let's go ahead and hit graph, and we get this. Now, you see my window is a little bit wonky. Like I only have a couple of things on there. So what you can do is go to the zoom button. That's the one that's red now. And then you see number 6 says zoom standard. So anytime it doesn't look the way you want it to, just go zoom 6 and it'll put it back out to centered at 0 and all of that. So that's what our function is going to look like. That gives us an idea of what we're aiming towards. Now, we need to pick a 0 to start with. And it looks like positive 1 is a good candidate. I can see that because that's where it crosses right there at 1. So when we do our synthetic division, that's what I'm going to choose to start with. Whoops, sorry. Here we go. So I am going to divide out 1 from my polynomial. So 2, 5, -1, -6 are our coefficients. And we'll just run through our synthetic division algorithm. And we get a remainder of 0. So that tells us we were right. That was a good place to guess to start with. And so now we get here. X minus 1, that came from the 0 that we picked. And then these guys tell us that we're left with 2x squared plus 7x plus 6. And we're trying to find the zeros, so we want that equal to 0. Now let's look at this, since this is a quadratic, and see if this is factorable. And it turns out it is. We get 2x plus 3 and x plus 2. If you need some help on factoring, you'll need to find another video there. I'm trying to keep it short for you guys. So that means our zeros, when we set each of these factors equal to 0, we get positive 1, -3/2, and -2. Those are our x-intercepts. Now don't forget, these graphs don't have axes, so we need to add them in. And I'm not going to graph anything just quite yet. until I see my y-intercept and know that it's all going to fit on my graph. Because if it's not, if my y-intercept was like 25, I would need to change the scale on the graph. So to find the y-intercept, we always do f of 0, which if I plug in 0 for all the x's, I'm just going to get -6. So it looks like counting by ones is probably fine. And again, the graph I was looking at on my graphing calculator looked like it fit just fine. So we're good. So let's plot what we know. We know that our x-intercepts are at +1, -3/2, which is -1.5, and then -2. So those two are really close together. And then we also know that we have a y-intercept at -6. So now we need to make some choices. We need to choose some other test points over here to help us get a good shape of the graph. Now, when we're choosing test points, we need to go on the outside of each x-intercept. So the farthest one, we need to pick some point on this side and some point on this side. And then we also need to pick an x-intercept that's between, or not an x-intercept, an x value that is between the x-intercepts. So I need something in between these two and something in between these two. It does not matter what we pick. We just want to choose convenient numbers for ourselves. So, I would choose to the left of -2, I'm just going to choose -3 because that's the next whole number. Now, between 1.5 and 2, there's not really anything good, so I'm going to do -1.75. I mean, really, we could just pick 1.7 or 1.6. Doesn't matter. It's just got to be between those two. In between -3/2 and +1, we already know what happens at 0. That's our y-intercept down here, so I think we're good there. And then we need to test something to the right of +1, so I'm going to choose 2. Okay, now I'm going to have to clear this off for a second. We can use the graphing calculator to help us figure out these points rather than plugging them back into the equation and taking a long time to figure that out. So let's go back to our graphing calculators. The first thing that I want you to do is you are going to go second, which is the blue button right here, and we want to get to table set, which is above window. So second, table set takes you to this menu. Now, you see here where it says the independent and dependent variable. Remember, independent is your x, dependent is your y. They're both set to auto. What I want you to do is change the independent to ask. That means we get to tell it what we want the x to be, and then it'll figure out the y. So just use your arrows to arrow down until you get there. Move your arrow over to ask and hit enter, and that'll switch it over to ask. Okay, now that we've done that, you're going to go second again, and then this time we want to go to the table, which is above the graph button. So second, table, and that brings us here. Now, if we had not set it to ask, if we had left them both on auto, then this would already be filled in with a zillion numbers. But since we set it to ask, that means we get to plug in whatever numbers we want there for x. Well, we chose to test we chose -3. So I'm going to hit -3, enter, and ta-da, it fills it out for us. And then we did let's just do 1.7. And then we did +2. And so that saves you all the time of having to type in that equation over and over again, plugging in. Now, if you don't have a graphing calculator, that's the only option that you've got. But so there are the 3 values that we want. So you can go ahead and copy those into your table. Now, I'm going to have to do some rewriting here since I had to delete all of that. All right. So that's what we had for our graph so far, and those are now the test points we got. Now, the last thing I would check is your end behavior. So we have an odd degree, and we have a positive leading coefficient. Based on what we did on the other side, that means our arrows should look like this. Okay. So let's plot our points. -3, -12. That's not really going to fit, but it does give me kind of an idea that point's going to be down here somewhere. I don't need to know exactly, I just need to know where to aim when I'm drawing my arrow that way. In between those is 0.324, so it's just really tiny. It's just barely going to come up above right there. And then at 2, it goes up to 28, which just means this is going to be really, really steep when we come over here. We don't have to get all the way up to 28, but we know that that's going to be way off the graph, so that side should be really, really steep. And so, whoops, I'm scribbling. Now we know that our graph needs to look something like this. It's going to come down like this, turn around just really quickly, come to the y-intercept, and then as we go through this x-intercept, it's going to be really steep, so we can just go straight on the rest of the way up. And so that gives us the idea of what our graph should look like. I am only going to post the next example online so you don't have to listen to a video again. I do just want to point out that one other option for finding the zeros when you look at number 2, this isn't something that's factorable, but we do know how to solve equations like this. To find the zeros, if I set this equal to 0, negative x to the 4th plus 2, I could start by adding x to the 4th to both sides. That gives me x to the 4th equals 2. And then remember, to just undo x to the 4th, we can take the 4th root. Whoops, I don't know what I'm writing. We can take the 4th root of both sides, which makes this a little faster. So we get x equals, now because the 4th root is an even root, we get plus or minus. And you don't really have a 4th root button in your calculator, but you can do 2 to the 1/4 power, which is the same thing, and you get plus or minus 1.19. So that gives you an idea of where your x-intercepts can be. The reason why that worked is because there are no other powers. If there was another x in there, this would not work. If there was an x cubed, this would not work. But because it's just x to the 4th and you're constant, that's another strategy that you can use. Alrighty, use the graphing calculators to help make this process go a little bit faster. And that is that. You have a worksheet to work on today.